Hello guys, what's up? Welcome back to A Coder's Journey. This is the first episode of a series I have decided to create in order to teach you how to implement the modular monolith architecture in .NET using Visual Studio 2029, C#, Web APIs, class libraries, maybe, I'm not sure, maybe clean architecture, and probably unit testing and many other important and useful topics. Like before, like the other recent playlists that I have created, I haven't set up the solution prior to recording the videos. I have prepared a document file for this course, which contains some code snippets, some tips that we are going to, study one step at a time, and then we are going to go to Visual Studio and implement everything using .NET. So if you want to learn how to implement the modular monolith architecture, if that's your intention, then I think you're at the right place. I don't know whether you have some prior knowledge about software architecture. I'm not sure whether you have implemented any specific architecture in your applications. But for those of you who are already familiar with monolith architecture, maybe microservices, maybe layered architecture, this series is going to be great. Again, if your intention is to learn how to implement the modular monolith, I invite you to watch the videos in this playlist to the very end. And I will probably also create another playlist for teaching you how to implement the vertical slice architecture. Now, all that's left to do for us is to go to the document file and start talking about the modular monolith architecture. This is the document file I told you about. This is something that I have created in order to, study some topics, some theoretical concepts about software architecture, modular monolith architecture, and then we are going to go to Visual Studio and implement these. So this tutorial will guide you through the process of building a modular monolith architecture using ASP.NET Core minimal APIs. We'll start first by understanding the background and motivations behind this architectural style, namely the modular monolith architecture, and then we will move on to building a sample application step by step. When it comes to learning something, there is no better way than to learn the theoretical concepts and then implement them in action, like something using Visual Studio. And that's my intention for this course. So let's move on. Introducing the modular monolith architecture. This section will provide some background knowledge. First, let's talk about the monolith architecture. So traditionally, applications were often built as monoliths. Monoliths means that all the application's functionalities are packaged and deployed as a single unit. So basically, you have one executable, and that executable is the only single unit of your application which contains all of your functionalities, all of your implementations, everything. The whole application is deployed, is created in like one single unit. And this monolith architecture has some benefits and drawbacks. This approach can be, of course, straightforward. It is very easy to implement, especially for junior developers. And at least initially, it is easy to deploy the application. It is easy to implement the requirements. You can move rapidly and implement the business requirements using this monolith architecture. Then we moved to the next architecture, which I suppose you are familiar with based on, your decision to watch these videos. I guess you are familiar with layered architecture as well. So when applications grow in size and complexity, like developing your application using monolith architecture can be very difficult and cumbersome. Therefore, we prefer to decompose the different parts of the application into different components, into different units. So we are not going to deploy the application as one single unit anymore, but rather we are going to have different layers, layered architecture. So layered architecture, which as the name suggests, compose the application into different layers, emerged as a way to organize the code base. This typically involves separating concerns into different layers, such as presentation or the user interface of your application, something like, for example, MVVM, right? Model view view model, or MVC, model view controller. So the V means view, means presentation. And when we talk about presentation, guys, we do not necessarily mean like some buttons and some text boxes that the user can, let's say, interact with. So the presentation layer can be an interface as well, something that you can communicate with, not necessarily some buttons, text boxes, and things like, UI elements. So we basically typically decompose the different parts of the application in the layered architecture into different layers: presentation, business logic, data access. I'm not going to talk about these because we want to move a little bit, fast in order to be able to implement things in Visual Studio. So the layered architecture compared to monoliths has a very big advantage. It helps improve maintainability and separation of concerns because the application has different, deployment units. Now, let me tell you something. Let me ask you something, actually. Suppose you have one single solution, right? Like this one in Visual Studio. And then you add different projects to this solution. One for your presentation, one for data access, one for data access, business logic, and presentation. As class libraries, or like, for example, for the presentation, let's say you go for like a WPF application, right? Now, my question is, based on these different layerings, different layers that we have in this solution, in this single solution, do you think you are using layered architecture? If your answer is no, then you're correct. So even if in the example that I just gave you, you are using different projects in the same solution in order to implement the different layers of your application, you are still using a monolith architecture. Why? Because your whole application is going to get deployed as one single unit. So this is very important to understand. Do not assume that by creating different projects in one single solution, you are using the layered architecture. That's not the case. You are still using the monolith approach because your application, even though it is, it contains different projects, again, it is one single deployment unit. But back to our note. The layered architecture, even though it has, again, some challenges, some drawbacks, which we are going to discuss shortly, was a step forward when compared to monoliths because it allows you to increase the maintainability and separation of concerns. And then the next architecture that I want to talk about is the microservices architecture, which I am going to create a playlist for, probably, to implement microservices in .NET as well. To address the challenges of large complex monoliths, such as scalability, limitations, and deployment bottlenecks, the microservices architecture was introduced. So in microservices, we break down an application into smaller independent services. When I say independent, I mean in terms of development, deployment, testing. So they are independent on one another. Different microservices can be managed by different people, by different teams of developers, and they can be developed, deployed, scaled independently of one another. So again, as you can see, when we had smaller applications with like few lines of code, like 100 or 1000, let's say, lines of code, the monolith architecture was a great choice. Then the complexity of applications grew, and then we realized that we need a more, let's say, layered architecture, which allows us to decompose a larger application into more manageable, smaller components. And then we moved on to the next phase where we introduced the microservices architecture, which was again a step forward in terms of scalability, deployability, independent deployability, of course. And it has many benefits and of course drawbacks, which we are going to again discuss later, probably in another playlist. I also want to take a moment to talk about distributed monolith, which is a problem when you want to implement the microservices architecture. It is a pitfall. It is like a trap that you may fall into. While microservices offer many benefits, they also introduce complexities related to distributed systems such as network latency, inter-service communication, and distributed transactions. Sometimes an attempt to adopt microservices can lead to a distributed monolith without you realizing it. You think you are implementing your application using the microservices architecture, but actually you have fallen into the trap of distributed monolith. In distributed monolith, the services are still like tightly coupled. They are deployed and they are not independently deployable, and the deployment needs to be coordinated. And this distributed monolith problem negates many of the advantages of microservices. Now, let me tell you something. Implementing an application using the microservices architecture is a huge undertaking. It is not easy to implement. And you need to have a very legitimate, reasonable reason to implement an application using the microservices architecture. And when you fall into the trap of modular distributed monoliths, you are let's say, experiencing the difficulties, the challenges of microservices, but you are not reaping the benefits that the microservices architecture has to offer. So I'm not going to talk about distributed monolith anymore here. I just wanted to, as I said, take a moment to talk about it. Now, one last thing before we move on. In software architecture, in software development, everything is a trade-off. You can't say that one architecture is better than another one. The domain of your work, the context of a project indicates which architecture to adopt. For example, if I want to implement a very simple personal application, which would probably contain, let's say, 1000 lines of code, I would probably adopt the monolith architecture because it is enough for this specific application that I told you. But when I want to build an e-commerce larger scale application where scalability is going to be very important, where I predict that the application will grow in size, I would not go with monolith architecture. I would decide to go with microservices. Even though microservices architecture is difficult or more difficult to implement compared with the monolith architecture, but for this specific e-commerce application that I told you about, this architecture will help me to implement the different things that I want to implement in my application correctly. So what I am trying to say is that there is no perfect architecture, and these different options that we have here are all good, and it depends on the context, on your project, and you can adopt whichever ones you want based on the requirements that you have in each project. Now, let's talk a little bit about the benefits and drawbacks of these different architecture, and I think I have already touched upon some of them, but let's talk about them again. So monolith benefits, as I told you, it is very simple to implement. And of course, at the beginning, you can move very rapidly. So the deployment is easy because there is only one single unit to deploy compared to microservices, which involves so many different, small microservices that need to communicate with one another. And the development is also easier, at least at the beginning. But as the application grows in size, it becomes a nightmare to implement new features and to deploy the application. Drawbacks can become complex and difficult to maintain at a scale, means when the application grows in size. Scaling the entire application, even for a small feature, and deployment bottlenecks. So, for deployment, when the application grows in size, using the monolith architecture means that for each single change that you make, you need to deploy the whole application, the whole one single unit of your application, which is not the case if you, for example, use the microservices architecture. Scaling the entire application, even for a small feature, again, becomes difficult. Anyway, layered architecture, the benefits compared to monolith, for example, improved organization and separation of concerns compared to basic monolith. Why? Because, for example, you have different layers: data access, business layer, or business requirements layer, for example, the layer that contains your business logic or business logic layer, and the presentation layer. But the drawbacks, still it is a single deployment unit. Do you remember the question I asked you? Similar scaling and deployment challenges as a monolith. Microservices, benefits, independentability, if that's a word, independent development, independent deployment, independent scaling of different services based on the load of the application, and of course it is technology agnostic. It means that you can implement your different microservices using different technologies. For example, you can have 3 microservices in a system. One of them is implemented using .NET, the other one using Java, the other one using Go, for example. Drawbacks, it is complex to implement. It is complex to deploy because it is like a whole distributed system that you need to manage. Inter-service communication, it is difficult. And there is this potential of falling into the trap of distributed monoliths, as we discussed. When you want to implement your application using the microservices architecture, there are so many things that you need to think about. After a while, you will probably decide to go or to combine your architecture using the event-driven architecture, and then eventual consistency comes into play. So there are so many things that you need to think about, that you need to consider, but of course it will all pay off, especially when the application grows in size and in number of active users. So the last part of this episode, modular monolith, which is the topic of this playlist, enhances the monolith. The modular monolith architecture aims to strike a balance between the benefits and drawbacks of microservices architecture and monoliths. So to remind you of the benefits of monolith and microservices, monoliths are easy to implement. You can move rapidly especially at the beginning. The benefits of microservices, they are great for applications that need scalability, that need to be developed and deployed independently of one another. So the modular monolith, at least in my opinion, strives for a combination of the two benefits that I just talked about. So it seeks to enhance the traditional monolithic architecture by introducing stronger modularity within the application while retaining the simplicity of a single deployment unit. So still we have like one single deployment unit, but we have modularity, means we have decomposed the application into smaller parts. This approach attempts to mitigate the complexities associated with microservices. I told you that microservices are difficult to implement, are complex, while addressing the maintainability and scalability concerns of a tightly coupled monolith. So that's it for this episode. I know that in the first episode, the things that we talked about were very, abstract, maybe theoretical, but I think they are very important to comprehend, because you need to understand why you need to learn another architectural style, modular monolith. First, you need to understand the reason, the motivation, and then when you understand the benefits, the motivation, the reason behind this new architecture, then it makes more sense to implement it using a real application, which is something that we are going to do starting from the next episode. So stay around, and in the next episode, we are going to go to Visual Studio and we are going to implement this modular monolith architecture using a domain of a company, like a fictitious company that I have thought about. We are going to address so many different things. We are going to use many different technologies, and I ensure you that you will learn a lot of cool stuff. So thank you so much for sticking to the very end, and I will see you in the next episode.